So let's look at problem 24 in the homework. The problem gives you the first derivative of function and looking for the second derivative. So conceptually, you are supposed to take derivative. However, I do want to bring to your attention, the x is not the usual x we have been dealing with. This x is the name of the function. So in order to feel more comfortable about the general idea, what you could have done is you could have rephrased the problem sign. It actually meant df over dx. So basically what I did is every single x, I write it as f. Every single t, I write it as x. So it feels more comfortable for us because it's the notation we usually use. So it's the function f of x, right? X is the original x is the name of the function, t is a variable. So the derivative of it is 7 times, every time I see x, I write it as f of x, and sine, and then f of x. So this is actually what's given to you, namely the first derivative of this function is 7 times itself multiplying sine times sine of itself. So they are looking for the second derivative. Therefore, I'm going to have 7 times f times sine of f takes derivative. Well, 7 is a constant, so I can ignore it by putting it out. Then the rest is a multiplication of two parts, so I'm going to use product rule. So it's 7 times the derivative of the first function and times the second part, add to the first function, multiply by the derivative of the second half. Be a little bit careful here. The second half actually is sine of f. That's the function sine x and f of x, two parts put together. So I need to do a little bit clear calculation down on the side. In order to find what's the derivative of sine of f of x, you should realize this is a composite function, so I need to use chain rule. The outside layer is sine x. The inside layer is f of x. So chain rule says you differentiate the outside layer and you substitute the inside layer function into it. The inside layer function, you take the derivative of it. So conceptually, the derivative should look like cosine of f multiplied by f prime of x. So let's write out my answer by putting it back to the right position. It's 7 times f prime times sine of f of x. Add to 7 times f times cosine of the f function multiplied by f prime. Well, the problem is I renamed everything. So technically, I shouldn't have f appear in my answer. F was my short form of my x, so I'm going to translate every single f back. So it is 7 times every single f translated back into x. So it's 7 times x prime times sine of x plus 7x cosine of x times x prime. Well, x prime, namely the derivative of x, is given to you, so you should make it super clear what are those. So I'm going to change x prime back to that. So it's 7 times 7x sine x multiplied by sine x. Like I said, I'm changing x prime back to what it's supposed to be, which came from the original question. And therefore, I have 7x cosine of x, 7x sine of x. So you could simplify it a little bit if you want to, but it's not required. So this is what we end up with as the final answer, right? Okay, so the idea actually is not hard. You are looking for the derivative of this expression, so you are going to use product rule. The tricky part is the variable or something that named is slightly non-intuitively, and I'm hoping by writing it like that, you can look at more like a little bit better. And also, I don't give you the structure of f. I give you the first derivative, and the first derivative depends on the f function without knowing what exactly is the f function. Well, of course, the other idea is to, based on this given information, will I be able to find the actual f of x? If I were able to find it, I could take second derivative directly, but that's something more advanced. To go from the derivative back to the original function, it's some kind of antiderivative calculation. We undo the derivative calculation. Sometimes the problem are too sophisticated. A simple undo derivative doesn't really work that easily. This is one of the examples. So we will need to get into the differential equation class, which is after you take calculus 2, you can take differential equation class concurrently with calculus 3. But bottom line, it's a simple change of notation. There's really nothing too fancy about it. Hopefully it's addressed your concern a little bit.